Hello geometry students, and welcome to the 6566 notes. Just wanted to let you know that this is the last section of chapter 6. It's a very short chapter, so your test is just around the corner. All right, we are going to go theorem by theorem here. There's a lot to start with, so we'll coordinate with its example. Let's begin with the two guys at the top, the triangle longer side and larger angle theorems. These are pretty easy to remember. If you can remember one, you can remember the other. The only thing you have to be careful is with your naming and your symbols. So let's begin with triangle longer side theorem. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Meaning, if I'm given information about the sides, I can also get some information about the angles. So let's take a look at this first example. Write in with me that AC is 10. So what I see are side lengths. And even though I can tell you how long the sides are, I can also order the angles. And I'm going to order them from we don't call angles short, really. We call them small, medium, or large, or small, middle, and large. Okay, so what we're going to do is we're going to write out who's the smallest angle, who's the medium size angle, and who's the largest angle. Again, I know that side information, and I can tell you exactly how long the sides are, but it gives me some information about the angles as well. So the smallest angle is across from the shortest side. So the smallest side here is 5, so the smallest angle is angle A. I don't know how many degrees it is exactly. We don't have the tools for that yet, but I know it's the smallest angle. The middle-sized angle is 8. And across from 8 is angle C. So I know C is the medium-sized angle here. I don't know how many degrees it is, but I can speculate it is the middle size of the three. And lastly, my largest angle will be across from my longest side. So the largest angle is B. I don't know how many degrees it is, but I know it is the biggest of the three. Now, larger angle theorem does the same thing, but the opposite way, or the other way around. So what we're going to do is we're going to fill in angle B is 100 degrees. And so I see angle information there. And it will tell me some information about my sides. I don't know exactly how long they'll be, but I'll know who's the shortest, who's the middle, and who's the longest. Let's begin with the shortest. The shortest will be across from our smallest angle. So find our smallest angle, go across from it. That's side AB. So side AB is the shortest of the sides. Find our medium-sized angle. That's 50 degrees. Go across from it. I don't know who or how many inches or centimeters BC is going to be, but I know it'll be the middle. And lastly, the largest angle is across from the longest side. So 100 degrees is the largest angle. That makes AC the longest side. So even if I'm not given any angle or side information, I can find out about the other. And so let's go apply that to example number 1. So let's say we're in theater class and we are constructing a stage prop of a mountain. And we're given some information about how this mountain's going to look. We're told, okay, the bottom of this mountain is going to be 32 feet long. The left slope is going to be 24 feet long. And the right slope is going to be 26 feet long. So we're told information about how long the sides are of this mountain. Even though I'm just given side information, I can actually order angles. And so if I were you, I would pay really close attention here to how you're writing your answer. So I'm told that I'm supposed to go smallest to largest, so smallest, medium, largest. And I would even just put your angle symbols in so that you remember, okay, I know I was given side information, but I'm labeling angles here. So the smallest angle will be across from the shortest side. Shortest side's 24 feet. That means angle L is my smallest angle. My medium-sized angle is across from the middle side. Oops, that's angle J. And the longest side will be across from the largest angle. And so here's 32 feet. That tells me angle K is going to be my largest angle. We are going to do another example of this. Go to number 2. I think we're going to leave 3 for class. So if I want to label sides, I'm doing short, medium, long, and I'm going to put my segment symbols in just so I remember, okay, do the names of sides. But before I can do that, I got to know how big all my angles are. Angle F is missing, but triangles add up to 180. So if I take 180 minus 51 minus 47, I can quickly figure out how many degrees that is. 180 minus 51 minus 47 is 82 degrees. Okay, so we're told to go shortest to longest. So shortest is going to be across from my smallest angle. So that guy's the smallest. That means side DF is my shortest side. Medium is going to be across from 51. It's pointing at EF. So EF is going to be my medium-sized side. And my longest is across from 82 degrees, and that is DE. Okay, so now you know how to order sides given different types of information and order angles as well. Let's learn our next skill. Our next skill is going to be the triangle inequality theorem. The triangle inequality theorem says that the sum of lengths of any two sides of a triangle has to be greater than the third. So what you're going to do is you're going to test all 3 sides. Do the sum of 2 of them, add to be greater than the third. So you got to make sure it's greater than AB, the sum is greater than BC, the sum is greater than AC. So that is much easier to see an example, but I want to make sure that we write not equal to. So equal to doesn't count, it must be greater than. So meet me on number 4. We're going to do A and B together. So tell whether the triangle can have sides with the given lengths. Show your work. So we are testing 3 sets of inequalities. So is 4 plus 9 greater than 10? We're testing is 9 plus 10 greater than 4? And is 4 plus 10 greater than 9? So you can see that I have all combinations of sides here. If I answer yes to all 3, I'm good to go. But as soon as I answer no, I stop. Okay. 13 is greater than 10. Check. 19 is greater than 4. Check. 14 is greater than 9. Check. Yes, this guy is a triangle. All right, make all combinations for part B. Is 8 plus 9 greater than 18? Is 18 plus 9 greater than 8? Is 18 plus 8 greater than 9? All right, so is 17 greater than 18? No, it is not. You don't have to go any farther. As soon as you realize one is not going to work, you stop. No, this is not going to be a triangle. The next thing that we are going to do is 5A. So with every triangle, if I'm given 2 side lengths, there is a range in which the third side could be. There are multiple possibilities that work. So we need to figure out that range of possibilities. So here's how it's going to work. I'm going to use that inequality again, and I'm going to call my third side x. So 14 plus 9 has to be greater than x. X plus 9 has to be greater than 14. And 14 plus x has to be greater than 9. So what you are doing is using the third side called x to see where that range is. So add these together. 23 is greater than x is greater than 5, and x is greater than -5. So we cannot have a negative side length. Disregard that immediately. We will always have that happen where a side length comes out negative, so immediately disregard it. Here's how you put together your final answer. Watch how I kind of glue these all together. X has to be less than 23. Notice the small part is pointing at the x. And x has to be greater than 5. So that's our range. You kind of glue those two answers together. So all the numbers in between 5 and 23 will work to be the third length. Okay, one more skill to acquire. Meet me back here at the hinge theorem. So let's say two sides of a triangle are congruent to another two sides. So you can see that there in the picture with the red tick marks. And the included angle of the first triangle is larger than the included angle of the other one. So 88 degrees, the angle between the congruent sides, is bigger than the other triangle's 35 degrees. That means that XW is bigger than ST. So if they had the same length of sides, a larger angle is going to open up the triangle than a smaller angle. The reverse works. If you have a side across from two congruent sides, this angle C will be the bigger angle, and angle F will be the smaller angle. I don't know how many degrees exactly, but it'll definitely be smaller if it has a side across from 9. In class, we'll do an example opening and closing the door. So watch for the door example for these to illustrate the hinge theorem. Let's see how it works on paper though. We're gonna do this guy. We gotta rename this example. This example is number 6, and we are gonna do A and C together. So, in order for hinge theorem to work, you have to have two pairs of sides that are congruent. I can see the red tick marks, and I'm gonna put in the reflexive side. So think about JM compared to LM. Remember, the larger angle is going to be across from the larger side. So therefore, JM will be the bigger side than LM. I don't know how long, but it'll definitely be longer than LM. Okay, we're told on C that PR is congruent to PS. That's the red tick marks. Put in your reflexive side. And we're given a cryptic piece of information here. We're not given a specific number. We're told that QPR, so let's find QPR. QPR is here. QPR is greater than QPS. So that guy's the big one. QPS is small. So what about, how does SQ and RQ compare? So if QPR is the big one, and QPS is the small one, this guy means this will be the smaller side, and this guy will be the bigger side. So SQ is going to end up smaller than RQ. So you don't need an exact number, you just need to know if it's less than or greater than. All right, we will finish the notes in class.